Prime numbers, right? They're a big deal to cryptography, as was just mentioned, okay? Which is really cool because it's like, what are the use of prime numbers? Like, why are they useful? No one thought they would be useful, but they are, okay? So therefore, one of the most important questions to answer is a number prime or not? Now, you know many prime numbers, okay? But part of the reason why you know these are prime is because, well, you've memorized the fact that they're prime. You didn't intentionally, but you've known these numbers for so long and they're small, you've worked with them for a long time, you're like, yeah, they're prime. If I give you some other number, right, can you test if it's prime or not? How would you go about doing it in a quick, efficient way? Okay. Now, there are lots of tests for whether a number is prime or not, and they are called, this sounds really cool, they're called primality tests. Okay? Yeah.
This is a wild guess, but does it involve like adding more digits and see if they add up?
Okay, so let's think about this for a second, right? One of the ways you might go about this is you might think of it as a divisibility test, okay? So there are very common divisibility tests like this. You know, for example, it's very easy to tell that this number will be divisible by 3 because its digits add up to a number that's divisible by 3, okay? So that's all fine. The problem with that, right, is that there are easy divisibility tests for small numbers. 2, 3, 4, 5, 6 is 2 and 3. 7 is even not that bad. 9's okay as well, right? But then after that, 11's also okay. But after that, you're kind of stuck, right? Like it just becomes so much more complicated. And if I want to know if this number is prime or not, I've got to make sure no number's divided, right? So it's easy to work out, is this divisible by 2 or not? No, because it doesn't pass the test, right? But that doesn't go very far to answering the question, is it prime or not? Okay. So I'm going to tell you today about 2 primality tests, okay? The first one is called Fermat's primality test. Fermat is spelt like this, format with an E instead of an O, but it's pronounced Fermat, okay? I think it's Pierre de Fermat, he's French, okay? So Fermat's test. Okay, so here's the idea, right? The number you want to test whether it's prime or not, okay, is P, okay? So is P prime is the question. Okay, here's the way Fermat's test works, okay? He says, look at this expression here, a to the power of P minus A, okay? Where A is all of the numbers, oh, that should be a 1, between 1 and P, okay? Now, if you work out what this is, okay, whatever that number evaluates out to, okay, if P is prime, then this number will be a multiple of P. This number is a multiple of P. Okay? Now, the important thing is, right, for example, if your number was, say, 100, okay, which we obviously know is not prime, okay, the way Fermat's test would work is that you're going to test for 100, we here, right, but you have to test all of the numbers for A between 1 and 100. So you'd have to test in A, you'd have to test 1, 2, 3, 4, 5, 6, all the way up to 99, and it's got to pass all of them, that's Fermat's test, in order to be prime. Now that's a bit intimidating, so let's just see how it works with a simple example. Okay? So let P equal 5. We know what the result will be. Let's see how it unfolds. Okay? What I'm going to do is I have to test all the values of A from 1 up until just before P. Okay? I'll let you have a think about why, by the way, and I'll ask you to answer this in 5 minutes. Why is there no equality there? I'll let you think about that. Okay? As we go through, you might work out why. Okay? So let's test this out. All the numbers under 5, right? Well, we start with 1. So 1 to the power of 5 minus 1. Okay? That's for A equals 1, which of course is 0. Is that a multiple of 5? It is. It's 0 lots of 5. 0 actually is a multiple of everything. He's going to be fine. Okay? Let's try the next one. 2 to the power of 5 minus 2. 2 to the 5, of course, is 32. So this is 30, right? So 0 is a multiple of 5, 30 is a multiple of 5. Let's keep going. 3 to the power of 5. Okay. 3 to the power of 5. Well, 3 cubed is 27. So you're going to have to do it again, which will give you 81. And you have to do it one more time, which gives you 243. Minus 3. 240, it works. Okay. Last one we need to test, 4 to the power of 5 minus 4. Okay, powers of 4. All right, we're going to go 4, 16, 64, 200 and, think about it, 56. The next one's quite common, you might recognize it. It's a kilobyte. 1024. That's 1, 2, 3, 4, 5. Yeah. 1020.
Hello, sir.
Oh, welcome back.
Yeah, right.
Are you're not welcoming back?
No.
You still got stuff to do?
No. Yeah.
You guys haven't caught fire?
Ralph, we saw your video.
Okay, bye. Good teleporting, by the way. Okay. Okay, it wasn't quite 5 minutes, but can you tell me why I don't need to go up to the end? Yeah.
Because if you raise it to the power of 8, then I think it kind of like, it's already multiple.
Okay, I think you're on the right track. How do you want to explain it? Of course, right? It's easy if you write it, isn't it? Right? Look, 5 to the power of 5 minus 5. They're all multiples of 5. So clearly the result you're going to get at the end will be a multiple of 5. You don't need to worry about this option, and you never need to worry about this option. Okay? Like if it was 7, it'd be 7 to the power of 7 minus 7. All multiples of 7, it's fine. Okay? So look, 5 has passed the whole Fermat test. Okay? As you can see, as the numbers get larger, it's very easy to fail this test. You only have to do one wrong, and it's over. Okay? So, this is foolproof though. It always works. As long as you go through the whole thing, you're guaranteed to find whether P is prime or not.
Isn't that a bit hard for really big numbers? Like
Yes.
17?
It absolutely is. Okay, so the reason why this is used ever is because, well, it works, and there are lots of tests. This is a bit strange, but there are lots of tests that kind of work, that are close to working, that work if, and there are certain conditions on it. This has no conditions. This will always work, and it is very slow, but that's kind of the drawback, right? It's like if you want to get it exactly 100%.
Do you want to
Okay.
explain